line. So it's really a happy moment. At the outset, it's my privilege to welcome all the participants and all of you to this event. And I'll make a very special mention of a very special person who is our distinguished speaker, Dr. Bibhuti Panda, sitting in front of you. And I, on behalf of the society, on behalf of all of us, on my personal behalf, I extend hearty welcome to Dr. Panda. Friends, distinguished lecture series is one of the programs of society, and that is aptly called DLS, and that DLS that is being done at a regular interval in our society, and it is aimed at sensitizing all the professionals belonging to the disciplines of geosciences, mining engineering, environmental engineering, etc., etc., through presentations like what we are going to do today, the presentations by distinguished speakers like Dr. Panda, who have national and international eminence. So today, this event is one of them, and it is the 12th episode of the DLS, our Distinguished Lecture Series. With this brief introduction, it's my proud privilege to invite our esteemed President, Mr. G.S. Khuntia, to please come and deliver the welcome address.
Good evening. Good evening to all our Executive Council members of SGAT, all advisors, Dr. Bibhuti Panda, Senior Geotechnical Engineer from USA. He is the chief speaker in this evening program. It is my proud privilege to welcome you all in this special DLS number 12 Distinguished Lecture Series. That was, this program was started by Dr. Owen Mahanti, my predecessor. He is here. It is no doubt a very wonderful program, and people have a lot of praises for this DLS because these are available for stalwarts all over the world. They are invited and they deliver speech. So now, this welcome address, I am G.S. Khuntia, a mining engineer from IIT ISM, having more than 25 years experience in iron ore mining operation only in NMDC and SAIL, Bhilai, Bokaro, Durgapur, Raurkela steel plant in their mines. I welcome Dr. Bibhuti Panda, Ph.D., Senior Geotechnical Engineer, Mining Department, Arizona, USA, as a distinguished speaker in today evening during his visit to Bhubaneswar in our SGAT conference room, where all our SGAT council members, guests from other professional bodies present here, and those online friends also present. He will be speaking on environmental consideration for the design of the Tailings Dam, an important subject for future prospect of mines, steels, power, infrastructural network for the country. As we all know, we have vast mineral resources like 31 billion tonne of iron ore, that is all grades of 45% and above cutoff, because now the country has decided the cutoff will no more be 56 or 58%, it will be 45 plus. And more than 275 billion tonne of coal reserve. We could produce 160 million ton today, and our plan is about 200, by 2031, we are coming by about 300 million ton steel. So many, all these iron ores, etc., will be used in steel industry, power plants, foundry, and in various industry. So only as we know, this regarding the iron ore resources, out of this 31 billion ton, only 11 to 12% is the high grade ore. That means 63.5 or 64% and above. And over last 100 years, we have been doing very selective mining, and almost all these, more than 50-60% of these high grade ores are exhausted. So it is now high time we have to resort to beneficiation process. Beneficiation is nothing but upgradation of Fe content or the metal content. So this is the only route by which we can survive. So this high grade ore, and so also is the case in coal and other mineral. It is high time that we go for intensive mineral beneficiation to upgrade iron ore to 63-64% Fe, and coal, etc., to 20 to 25% ash content for our metallurgical industry. Once we go for mineral beneficiation, the processing waste, which is about 15 to 20% by volume, in iron ore we call it slime. Slime, which is the processing waste that is stored in a tailing pond, and for that a tailing dam is required. 15 to 20% by volume discharge in high density polythene pipes of 18-inch to 20-inch dia. We call it slime, to store in a tailing pond needing tailing dam. I had good fortune to work in cell units and in NMDC units, who are almost pioneers along with Tata Steel, that is Noamundi mine. Noamundi mine, Tata Steel, they have resorted to this mineral beneficiation from 1956 onwards. Now almost all bigger iron ore mines operator, more than 2 to 3 million ton per annum, they are going to resort. By upgrading the productivity of the steel plant, because unwashed iron ore, the productivity in the steel plant is very poor. It is 0.8 or maybe 1 ton of hot metal or crude steel per cubic meter of blast furnace volume. If you resort to this mineral beneficiation, go for OBBP, ore bedding blending plant, and go for extensive this averaging facility, etc., you can go as high as 2.5. Imagine 1,000 cubic meter of blast furnace volume producing 1,000 ton a day. That will come 2,500 ton per day. So the profitability will be extremely high. So by upgrading the productivity in steel plant improves from 0.8 ton per cubic meter of blast furnace volume to as high as 2.5 crude steel per cubic meter of blast furnace volume, making huge profitability. Some of the iron ore mines like Barswa, in Barswa iron ore mine, this through HSCL, Hindustan Steel Construction, the tailing dam was constructed. I have supervised that myself. And Tiruvuru mines, Megatuburu, I was basically, initially I worked in NMDC mines. And the NMDC organizations, particularly Kiriburu, Megatuburu, these were truncated and came to Steel Authority. Then we came to Steel Authority. So the Barswa, Kiriburu mines, that is 1960 to 75. So design of the tailing dam, its construction, evacuation of slime for further improvement by spirals, hydrocyclone, jigs, etc., from 50% Fe to as much as 64.5 was possible with total recovery of 85% Fe from the 100% ROM, run of mine. However, this needs elaborate arrangement for water, thickeners, tailing dam management. Sometimes we do the sampling of the slime and if it is 58 to 60% Fe, with iron ore fines, we used to extract by putting a shovel and dumper, etc. And with 80% normal iron ore fines and 20% this recovered slime, we mix it with lime dust in RDCIS Ranchi, Research and Development Ranchi. We have seen that the productivity of the sintering plant or pellet plant doesn't go down. So now the need of the hour, the future roadmap of mining industry, call it bauxite, call it iron ore, etc., is to go for this process. And if we have very large number of small mines, they can aggregate, and we can go for a central bedding blending plant, and this will be economical. So with this, I conclude my this welcome address. I printed a few papers also in World Mining Congress on this. That book was not traceable. I have submitted a couple of copies, but I will try to give it to SGAT also. Thank you.
Thank you, sir. So now it's really my proud privilege to give a very brief introduction of our distinguished guest. And just let me go like this. After passing BSc with Geology Honours from Ravenshaw, Dr. Panda did his post-graduation in Applied Geology and Engineering Geology from IIT ISM Dhanbad. Thereafter, he was a teaching faculty in NIT Rourkela in Mining Engineering Department, where he was teaching rock mechanics. In year 1991, he left for USA for higher studies. He did his MS studies in mining from University of Utah and Ph.D. in groundwater from University of Arizona in US. He joined consulting field and obtained professional civil engineering license in USA. Currently, Dr. Panda is a senior geotechnical engineer for AECOM, the world's leading infrastructure consulting firm located in Phoenix, Arizona. Dr. Panda has more than 30 years of professional experience in the geotechnical, transportation, mining, and hydrogeology field. He is involved in many tailings dam projects as a lead project engineer and task manager for the design of new tailings dam and expansion, operational activity, monitoring, and closure of existing tailings dam. He has successfully guided a research effort to apply INSA technology in mining. His research project won Engineering Excellence Grant Award from American Council of Civil Engineering Company for the year 2010. Currently, he is a board member of NCE's PE Committee in Mining and Mineral Processing. He is the Vice President of Society of Mining Engineering PE Committee. He also served as member of the Selection Committee for NASA Postdoctoral Fellowship for International Students in Earth Science field. With this backdrop, I would now request our President just to offer a bouquet to our distinguished speaker on behalf of all of us. For kind information of our distinguished guest, Dr. Panda, I will speak 2-3 lines on SGAT, Society of Geoscientists and Allied Technologies, aptly known as SGAT, is a professional body dedicated to promotion of mineral development activities in India. Started in 1980 by a handful of eminent geoscientists of the state of Odisha, SGAT has grown manifold by attracting scientists and allied technologies representing disciplines of geology, geophysics, mining engineering, metallurgy, environmental science, mineral process engineering, etc. from different parts of India and overseas. Our membership strength is 920. Within more than 4 decades of its existence, SGAT has contributed significantly in the mineral development of the country. With this, it's my proud privilege to invite Dr. Panda to make his presentation. At the same time, I would request Mr. A.B. Panigrahi, our Vice President, to kindly moderate the question and answer session after the talk is over. So in the meantime, I would request all the distinguished participants to send their questions in the chat box only, which can be answered after the end of the presentation. Further, I would request Mr. Tilochan Mahanta, General Secretary, to extend necessary support for the smooth sailing of the session. Dr. Panda, please, to start the presentation. Thank you. Thanks all.
Okay, thank you for the introduction. And I will, today my consideration. Hello. Okay. What is tailings? First, the word tailings. In mining field, when I was studying, tailings was much popular. But now, this tailings known by most of the people, and we are seeing them also in the newspaper. Good. Okay. So basically these tailings are fine-grained waste material, and that is produced in mines, mainly due to crushing, grinding and processing ore minerals, again coming from the beneficiation process, also from the washing process, also from the, like in the coal mines, it's the coal ash, they are also kind of tailings, and also from the bauxite mines, which we call red mud, that's also a kind of tailings. Any byproduct from chemical reactions within the process, that is like gypsum, so any fine materials are tailings, and the problem is how to store it. We call it waste management. And initially when people started doing tailings dam, mainly the idea came from the regular hydro dam. So but these two structures are not same, they are different. Though the concept of hydro dam was enforced into the tailings, and people followed the similar things, like whatever, like we do seepage analysis, we do stability analysis, we look for the water management. Most of the concept came from the hydro dam, but there are differences, and let us see, like again the tailings dam store the solid and the water, runoff water, while the water dam, it only store the water. So that's the main difference. Again, the operational life for tailing dams, we say it is between 5 to 40 years. So after 40 years, we are also doing something to the tailings dam. They are no longer the tailings dam. They will be something else, which will come. But water dam normal lifetime is like 100 years. And construction period, it raised over the operating time. Like we say that it's 5 to 40 years, so it takes actually, construction time is 40 years for the completion of the tailings dam, while water dam generally constructed within 1 to 3 years. And in terms of engineering design, it can go from medium to high level depending on the site condition, while the water dam is mainly considered like a high level design. And dam section, the actual dam section varies with time. So compared to tailings and hydro dam, we can say that hydro dam is a static structure, while tailings is a dynamic structure, because everything changes with time. Our quality assurance and quality control is not that high level, but for the water dam, it is always high level. And failure. Failure of tailings dams not only cause the flood of water, like flooding with the water, also with the debris. The water is charged with the debris. So it is a debris flow. While the water dam, it is mostly the water. And in the tailings dam, like I mentioned, the operational lifetime is 5 to 40 years. So after 40 years, the tailings dam need to be closed. So that is also another part of the design of the tailings dam. We have to close it. And in this one, like I will not go into the closure, but what is the role of closure? Like what is the concept behind closure? That it is after the closure, that structure is environmentally, geotechnically, and in all aspect, it is a very, very stable structure for infinite time. That structure will be completely stable. So that's why we completely close it, like we cover it. We put a cover and close it, and it is in future it will not affect the environment. And so the main design comes from the environmental considerations. Because of this, lot of design is being considered to address these issues. So the most important is the water contamination. It's still not working right. Okay. Most important is the water contamination, because we know these tailings contains heavy metals and toxic chemicals, and also there is acid drainage, mostly from the rock, acid rock, there is acid drainage, and they will affect surface water, any river, lake and creek, and also the groundwater. So that's the most important parameter which we have to definitely consider. And mostly in US, we have all environmental agencies like EPA, and also our state agencies. Every state has the environmental quality division, and they take care of the law is very, very strict to control the any pollution, water pollution, either surface water or the groundwater. Then it also the soil contaminations. It affects the soil and vegetation and also agriculture. Then the ecosystem, the plant species and wildlife also being affected. Air pollution, definitely the dust, because it's the very fine particle, and mostly in the dry climate, which is the climate where I am working, mostly in southwest of the US, is very dry and windy, so the lot of dust generations there. Again, the failure. So the dam failure is what driving all these studies and all this technology, new technology, is because of these failures. And also the landscape alteration. So we can see that when we start the tailings, we again acquire a big area and develop this dam. and when we close it, we again alter the landscape. So we have to again see that environmentally they are all stable. So to address all these issues, we are following the concept. So the tailings design concept first start with a conceptual design, and then the dam design start with a starter dam, and then the operation continued, that with time the tailings are raised, and finally the closure. So in all these 5 stages, we'll have to have design. The basic design services, we see there are 4 important players in it. Mostly in US, majority of the design is done by the consultant, and then the owner of the mining companies, then the agency like environmental agency and also water department agency, and there are other agencies also involved depending on the like forest, and also the department of mines, they are all involved, and then the contractor who does the construction. So in the basic design services, we mostly carry out, these are the major component, and we start with the historical data. Any site we go, we look into the historical data, and the numbers are who are the involved in these design services. Then we start with the site characterization, then the tailings characterization, because tailings can vary depending on whether it's a copper tailing, gold tailing, iron tailing, nickel tailing, chrome tailing, whatever, or bauxite or coal. The characteristics will be completely different. Then comes the planning and site selection. We have to be make sure that our site is the site selection will be a better site, and then we come from the site classification, then the design, then comes the construction, then comes the operation of tailings, then closure, then post closure, like after the closure also it run like we do lot of monitoring which continue for forever, that's called post closure. Then the risk management, we will have to look into every stages, we look into the risk involved. Currently this tailing monitoring system is getting a big attendance, because we have to make sure that if we can identify if that tailings dam will fail or not, because after failure we cannot do much, but if we can identify before failure, then definitely we can do some remedial measures, and for that the monitoring system is very important. And then after the failure, we prepare with the emergency preparedness and response planning, that should be there. So siting, we look into the tailing specific factors. The most important thing, like what I see, the difference between hydro dam and tailings dam. Hydro dam kind of, we know it has to, we are stopping the river, like the flow of water. So it will be, structure will be very strong and protect the water force. And most of the hydro dams are, they vary in properties, but majority like we follow the same material. But with the tailings, we see that material is completely different from site to site. So for a particular site, whatever design method or things we adopt, not necessarily we can adopt the same thing in the other site. So that is the most important thing. So that's why the site specific factors are very important. Again, the mill location, because we are transporting the material from
mill to the tailings. So we have to make sure that it is not very far from the mill. Topography plays a very important role in the site selection. Then the hydrology. Most of our dam design, we are very, very particular in the hydrology because we know that the rainfall and the water balance, those are the most important factors when we design any reservoir. It is also same thing. There is not much difference. Geology is also a very important factor in the site selections because we have to make sure the foundation is strong of the tailings dam, because some of the tailings dam, one of the tailings dam I designed, which when it will be completed, height will be 1200 feet. So for those kind of very high tailings, definitely we need a strong foundations. So the seepage and foundation, they all depend on the geology. Then the groundwater. Groundwater also plays a very important role because in our all environmental consideration, we have to make sure that our groundwater is not contaminated. Then the foundation and seismicity. Seismicity is also a very important factor for the siting. What are the criteria we look into when we go for the siting criteria? Is the geotechnical and geological conditions, hydrologic and climatic factors, construction and operational factor, depending on if we are doing a thing which is at the remote, definitely our construction and operational factors will be different. Seismic activity, all these environmental consideration, then economic factor, because we know mine and economy, they go parallel. If it is cost is high, then definitely we cannot do that, because all the mines, the economy is always the most important factor for all the mining activity. Social consideration, that's a very important factor in the tailings facility, because some of the tailings facility, if it is close to a town or a popular area, so we have to again take care of the area there. So the part of the, which I will discuss later, part of the tailings guideline is we have to take care of the surrounding areas. Like if there are villages or populated areas, we have to make sure that those areas are not affected by the tailings. Then tailings characteristics and tailings design and regulatory requirement. Regulatory requirement definitely varies from place to place, country to country is different. Coming to the main construction method for the tailings, in 1980, when this kind of proper design of tailings, like tailings dam started in 1960s, but around 1980 they come up with a particular design, how we can design the tailings dam. So three important methods were developed. One is called upstream method, which I am a little bit explain that. This upstream method starts with a starter dam, which we call a starter dike. It's a small starter dam, like any hydro dam. That is the structure. You can use rock fill or sand or whatever material. And then we start depositing the fines. And these fines are till now, like there are other method of like changing the fines into more, like we call it a dry stack or a filtered tailings or a cake. But so far, the slurry method is the most important method for the design of the tailings dam. So this slurry material came and deposited in the upstream side of this starter dam. And then in the upstream dam, the advantage of upstream dam is the material deposited before now become the foundation of the next level when we go to the next height. And in this upstream starter dam, after the starter dam, mostly in the upstream construction, the tailings are used, because tailings also contain fines and some coarse material. Like there are some coarse material like fine sand and clay. That is what the tailings is. So the fine sand kind of material used as a starter dam, like the next level of the starter dam. Okay, next level of the starter dam, and then these are all the fines. And then we have it is called supernatant pond. That pond is created further from the dam. So this is the basic structure for the upstream constructions. And always we prefer there should be a beach, tailing beach. And the normal criteria we follow that it should be minimum 2,000 feet wide. That beach should be. But most of the tailings dam I have visited, that's very difficult to maintain that beach, because a lot of surface water also gathered in the tailings, so water can be there. So this is kind of the upstream tailings, and this upstream tailing dam is almost 50% of the tailings dam is the upstream tailings. It is very, very economic. You don't need any additional material. You can just build it and then you are good. So initially 1960 to 1980, a lot of people built upstream dam, but the problem started around 1980, when they started to fail. And when we see the failure, almost 60% failure is the upstream dam failure. So then the people, this is kind of a structure, upstream dam once it is built. Then go to the downstream. So because of the upstream failure, people consider the downstream. So it is the same concept, but we use a filter into it, because any water coming into the dam, because there is water can come into the dam, and to protect that water, to guide that water, we put the filter. And in the downstream, all these dam is not the tailings. These are all the hydro dam, the dam material, like rock fill or things. So they will be always, when we raise it, we see that it is progressing in the downstream side. It is nothing going into the upstream. So this is most stable structure, but you can see compared to the upstream, the downstream took major area, like how much area it take downstream, and also the material, when you construct the dike, the dam material, it is very expensive structure. So then they come up with another one, which is called central line dam, which is in between both. Like it is not completely going downstream or totally on the upstream, it is in the middle. So here it's basically whole starter dam is constructed or raised vertically. It's going up and up. You can see that as we go, it's up and up, and also the same filter material is used for the drain the water here. This is also the central line method. Again, the similar hydro dam also people have used. Water retention type structure people used, but again, in the water dam, you will have an impervious core, but to find this impervious core is very expensive. So very small areas or small sites, you find this kind of structure also. So these are the, like how the tailings are being deposited. It's kind of a single point. It can be a single point discharge. I said lorry will be discharged here. and then it can be a spigoting, like there is a line which goes parallel to the tailings, and then there are these small perimeter spigots, and then they deposit the tailings. But the most important one is the hydrocyclone, the cycloning tailings. What it does basically, the cycloning tailings, in particular the upstream site, we use it like it can, like it's called overflow and underflow. Underflow is the sand kind of material, and overflow is the clay kind of material. So this underflow, the sand material, it divides the underflow and the overflow, the cyclone. So the underflow we used is as the dam, like when we raise it, the main dam is used by the underflow, and then all the overflow is deposited in the pond. And this cyclone is now the trend, like most of the tailing sites, they are using the cyclone. Again, the site characterization, we normally do same geotechnical investigation, but here the most important is the cone penetration test. Like when we try to get any material, like the test the material from the tailings or to characterize the tailings material, this cone penetration test is the most important one compared to what we do in the normal drilling like SPT or other method. And besides drilling, also we do our hydrogeological evaluations and also environmental assessment, and also we do some geophysical testings also. So these are all the things, I put them as a summary. Before the design of the tailings dam, we determine this, like the storage capacity, tailings properties, we do also modeling, and all these things are being in the design case, these are considered. That is what I was telling you recently. We are also, it's under, all things are under research, and people are trying to find what are the things we can develop more. So from slurry, depending on the solid to liquid ratio, like if we extract or dewater the slurry or the tailings, then this can become a paste, and if we dewater further, it can become a cake. So these are also new technologies coming, and I can predict that in 20 years from now, slurry can be obsolete, because this filtration technology is developing rapidly, and we are all trying to see how economically we can filter it, because right now the cost of filtering is very, very high. So that's why it is not economic. But in 20 years from now, it will be mostly this will work. And definitely with the paste, like when we reduce the water, then definitely the space will be reduced, and also this will become more stable. The structure will become more stable. Then the GISTM. So all these things started, I will show you that failure of the tailings dam in 2019 in Brazil is called Bernardino tailings. And that is the game changer in the tailings history. And that 2019, after the failure, because it was a huge, you will see that video, because that time somebody was there who shoot the video at the time of failure, because they were doing some drilling activity during the failure. So one of the cause of failure was also, they say, the drilling. So, and because of that, this global industry standard on tailing management developed. Now, almost, I'm not sure about the status in India, but what I'm talking, people are not considering this GISTM is still not considered here. But it doesn't matter. Even in US also, there is, our law is not telling us to follow the GISTM, but most of the agency and most of the owners also agreed to follow the GISTM. And this is the deadline coming from a UN site, like they want whoever agreed, because it was optional. They invited all the owners to agree, and whoever agreed, they have agreed that they will complete this GISTM by August this year. What is GISTM? They come up with 6 key elements based on this, like accountability, planning, risk management, change management, emergency response, and review and assurance. And they come up with, these are the 6 major framework. They come up with 15 principles, and that includes 77 individual requirements. So we will have to look into all these things and see that they are compatible with all the site is compatible with GISTM. Then it will be approved by the GISTM. And also they come up with the key role. They created a key role. Like there will be for each tailing site. It's not that it is not for each site. It is for each tailings dam, because in a particular site there may be 5 or 6 tailings dam. For each tailing dam there will be all these key roles. So there will be a responsible facility engineer, there will be an engineer of record, there will be an accountable executive, and there will be an independent tailings review board. So you can see that you need so many people for one tailings dam, which is creating problem everywhere in the world. That's why the tailings in future, many there is a big any new in the mining area. If anybody considering tailings as a carrier, this is the right time to go into that, because worldwide there is a shortage of people. Because you see, you need so many experts. These are all experts in the things, and even we do not have people who even familiar with tailings. Then the level of review, there will be 3 important review, like annual performance review for each site. There will be a dam safety review for every 3 years. There will be this independent tailings review board review every 5 years. So for each site, they will have to that. And each site should have a design report, construction record report, operation, maintenance, surveillance manual report, emergency preparedness response report, and annual performance report. So this is what the GISTM is telling to do for every site. So in the end, let us see this thing, because this will show us how devastating what happened. Video, this was a video. Why it is not running? It was working. ଗୋଟେ ଦେଖିଲ ଭିଡ଼ିଓଟା ଏଇଟା ରନ୍ କରୁଥିଲା ହଁ ଏଇଟା ଏଇଟା କି ଏଇଠି ଓ ଇଣ୍ଟରନେଟ୍ କନେକ୍ସନ୍ ନାହିଁ ଆମର ଆଚ୍ଛା ମୁଁ ସେଠି ଯୋଉ ଦେଇ ସେଥିରେ ରନ୍ କରିହେବ ସେଠି ଯୋଉଟା କପି କଲେ ଆଚ୍ଛା କୋଉଟା ୱାଇଫାଇ ମୁଁ ଇନିସିଆଲି ରନ୍ କରୁଥିଲା ହଁ ହଁ next Narayan. ସେ ପାସୱାର୍ଡ଼ଟା ନେଉନି ଭୁଲ ଅଛି ଆପଣଙ୍କର ସେ ଯୋଉଟାରେ ଆର ନହେଲେ ଆର ଲ୍ୟାପଟପ୍ ଲଗେଇ ଦେଇଥିଲେ ହବ ସେଥିରେ ବି ରନ୍ କରୁଥିଲା ଗଲା କନେକ୍ଟେଡ୍ ଓକେ ଆସୁନି ସେ ଇଏଟା ସିମ୍ବଲଟା ଆସୁନି ଆଉ ଥରେ ରିଓପନ୍ କରିବା enable content yes okay we can see now huh এটা আমি ক্লিক করব এইটা ଆଉ ସେ ଯୋଉ ତାର ୟୁଟ୍ୟୁବଟାକୁ ହଁ ଏଇଟା ଆସିଲା you can see that how quick it collapsed yeah you can see that how quick it collapsed and then the most important is you see there is a train line going at the end you will see that what happened to that train line and there are like big waste dump in front of the tailing also you can see that those you see this is kind of a wave it's called tailings wave Yes. You see, when this slurry or the tailings slurry is coming, it doesn't matter like what is in front of it. So that's why there is a remedial measure also. People think like we can put some berm in front of the tailings and that can stabilize the tailings, but may not be. You can see that like this whole dump is gone. it it's like that's why it's called dynamic. It's like earthquake. It's like earthquake. Huh? No, like there was a creek. It went into the creek and it went like 30 miles and further also. And there was a dam in that creek where it stopped. So here you can see that train, that bridge, train line bridge is gone, like completely gone. Yeah, that train we saw, it was passing by. That bridge is completely gone. Yeah. So this one uh, created there were 15 engineers were arrested after the event, and close to 300 people died, and a big there was a surrounding village was there completely wiped out. That village was wiped out. 300 people died, and 15 engineers are in jail. The case is still continuing in the last. It is this is the one. Yeah, that's the end. So the case is still in court in German, but recently another verdict came last year for a 2015 event, and also that event happened in Brazil also. And in that event, the court, Brazil court, fined $30 billion to three mining company. You can see that $30 billion. After this event, that's why the GISTM, they came up with the GISTM. The Bank of London, there is an investor group, they created a fund of $20 billion. Fund was created, and their plan is to look over all the tailing sites in whole world. And their plan is to every year they will spend like $1 billion will be spent every year to monitor that and characterize that and make sure those tailings dams are stable. So that's why this thing came. And the last one I want you guys to show. Let me see. Yeah. What happened? It আসলো anything? Okay. Okay. We next week I'm going to also present more details on these tailings dam for a short course organized by IIT Dhanbad, and that the this one. If anybody is interested, they can attend this course. This is a 5 days course, but thing. Hello. So in this June 23rd to June 27, anybody interested can attend that, and this will be a, I think, very good opportunity to learn more on the tailings. And at the end of this course, IIT Dhanbad will give also a certificate to everybody. And definitely anybody interested in having a career in tailing side, this will be an ideal opportunity for them. Yeah. So now, okay. Mm-hmm. Uh-huh. Yeah. Yeah. Mm-hmm. Mm-hmm. Okay. Uh-huh.
I suggested them also.
Mm-hmm.
I suggested them also.
Mm-hmm.
Please go for a wet
Okay.
process. That means tailing dam and all
Mhm.
those things
Yeah,
beneficiation. Because in the, if not today, maybe after 20 years, all
Mhm.
Indian mines iron ore,
Mhm.
if not singly, but maybe by a cooperative number of small mines
Yeah.
amalgamating and
Mhm.
joining
Mhm.
for this process.
Yeah.
So
Yeah,
I have
definitely.
suggested that some of your engineers should be
Should attend
to this
attend.
program,
Okay.
and they will learn in advance.
Yeah.
So that will be
It
good
will be helpful. Yeah.
about this program.
Okay. No, thank
So
you.
it is for
Yeah.
our entire mining industry in
Mhm.
India, particularly
Yeah.
in iron ore, also in bauxite
Mhm.
and chromite, etc.
Mhm.
People should attend this program.
This-
This will be useful.
Yeah.
Thank you.
Definitely. Thank you.
Thank you. Thank
Any
you.
questions?
I profusely thank Dr. Bibhuti Panda for this exciting presentation. And particularly the last video says it all, how important it is to monitor and to take care of the tailings dam. So now the moderator is Mr. A.B. Panigrai. Many questions are in the chat box. So I think Mr. Panigrai, please, you take it forward.
Okay.
All the questions, please.
Mhm.
By Dr. Panda. Excellent presentation by Dr. Panda. The first question is not exactly a question, but it is a information also. In India, after this 2019 Brazil tailings dam disaster, in India, it is from Mr. SK, I think Mr. Srinivas Suraj Prasad. Okay. In India, all 4 alumina refineries of Hindalco
Mhm.
are ready with filter press technology
Mhm.
for red mud handling and management.
Mhm.
The Central Pollution Control Board has mandated
Mhm.
to install filter press in all the proposed and existing alumina refineries. So this is, besides this, as per my information, Hindustan Zinc Limited is also having a dry tailings dam.
Okay.
Now the concept of dry tailings dam have come
Mhm.
in view of the disaster.
Mhm.
In fact, when we started with this slurry type
Mhm.
tailings dam.
Mhm.
Later on, it became zero discharge tailings dam,
Mhm.
and now it is dry tailings dam.
Okay.
So now, for the information of the house,
Mhm.
the one of the biggest iron ore beneficiation plant,
Mhm.
which is coming up in Surjagarh by
Mhm.
Lord Metals.
Mhm.
Recently, in the June 2025,
Mhm.
the Environmental Appraisal Committee
Mhm.
has recommended. The Environmental Appraisal Committee has recommended for 45 million tons of BHQ processing plant,
Okay.
which will generate 31.5 million tons of tailings.
Mhm.
But with technology, they are going to reduce the moisture content,
Mhm.
which is usually about 40 to 50%,
Okay.
to down to 20%.
Okay.
Now, I would like to ask you
Mhm.
a question.
Mhm.
Worldwide, what is the law on
Mhm.
dry tailings dam now?
Yeah. So dry tailings like dry stack concept is coming up. and the law and regulations are not still there, but if we follow the GISTM, it is exactly it should follow everything what GISTM is telling us. Like all the procedure followed for this study. Give you one example, like in one site, we were designing a dry stack, and in that particular site, the dry stack they had close to 15% moisture content. They have reduced it to 15% moisture content, and then the original in the original design, they found like, because the main part of the design, what we see when we look into the what is the base flow, like the telling there. So any water from the base flow, because that is the concept. So modeling for that, but some using some empirical model, they selected, the designers found that like 10 GB, not much, and when it was reviewed by the third party found that this method is flawed. Why it is flawed? Because the dry stack, you will have also consolidation of the dry stack, because when you compact it, because compacted. So during consolidation, definitely flow will be more, because what we see, it contains water and we put some weight into it, we'll see that. Their thing is that the original designer, they ignored the consolidation. So then the owner told them like, okay, can you help us that? So they also did the design, and then they come up with, instead of 10 GPM, they come up with 800 GPM. You can see that it's only 15% moisture. But if you look into the area, how much volume, 800 GPM also can be possible. So that's the project came to me, and then the client wanted me to look into that. Again, we looked into a lot of things which, like, right now we don't have time to go through that, but I came up with max flow will be 300 GPM, but average will be 50 GPM. That's what we came up with. So again, we see the dry stack. I have also looked into some of the dry stack in Africa. They have failed also because of the same issue. And in all these tailings, because we saw the tailings, but there is a dam also. Like I said, the starter dam, and also the dikes we developed, like the thing. In theoretical concept, we are saying these are all drained and they do not contain any. But in reality, water is always there. And those water, we are monitoring those water using lots of piezometers right now. Most of the tailing dams, existing tailing dams, will be monitored through these piezometers. And when we see those piezometer and the pore pressure reading, some can be very high also. So that is the most important thing, whether it is dry stack or slurry or any dam. So the monitoring and all the systems will be all same. And we'll have to also understand that even if dry stack, there is still 15% moisture, and those 15% moisture is also important.
Next is a question by Mr. Ramnath Praharaj, our senior member. Does use of geosynthetic liners help in stabilizing the movement of tailings in the dam?
No, like, again, the liner is not used in the like for the stability. Most of the things like right now, most of the agencies, mostly I deal with the Canada and the US, the agency like that, because those liners, if we put the liners, then definitely it protect our groundwater. There will be no flow because liner will control, it will be no flow. So that's why you do that. And also geotextile, recently I designed one closure. Actually it was a bauxite closure. Because of the client confidentiality, I cannot disclose much, but in the bauxite, closing the bauxite like red mud is very, very difficult compared to our copper or iron ore or things. Because in the bauxite, those red muds, they don't have any strength. They are like liquefied. So we are using a geotextile called geogrid, and that geogrid will take over all. We cover, like in the closure part what I mentioned in the beginning, like after the end we have to close it. So how we close it? We put a cover in it, and cover thickness can be 20 feet to 25 feet thickness will be those covers, because it will be designed such a way that the water doesn't stay there. It will be slope. See, so when you slope, the thickness will be. So those, when you again you are loading, when you put those cover in the tailing, you are loading there. So that's why also geogrid. So you use mostly in the cover, we use geomembrane mainly for the flow, and also we use geogrid also. But those things are very new and it has not been used much. And in my design, I mentioned that we'll have to do pilot testing and check everything and then come up with the design.
There is another question from Dr. S.K. Reddy.
Mm-hmm.
Which one is the best procedure to be adopted to remove the tailings from the tailings dam? 1. Sequentially remove the tailing materials, embankment and dry tailings. 2. Make a entry by breaking the embankment and remove the dry tailings.
No, the idea of removing the tailings from the tailings dam, it's not a easy procedure. It's not a easy procedure, because how will you extract the tailings? These are mainly, even I have seen, even after 50 years also, they are mostly slurry there. It just stay there like a slurry. And excavating those materials, you will have to again pump it, and that's a very expensive procedure to do that.
There is a question from Dr. Owen Manti.
Mm-hmm.
There is a question from Dr. Owen Manti, our past president. A tailing pond in case of iron ore is a source of iron in large quantities.
Mm-hmm.
Are there where the material from the iron ore tailings dam can be regularly extracted? Are there dams where the material from the iron ore tailings dam can be regularly extracted?
Means you can again recover iron from that.
Correct, correct.
I have no experience on that. Yeah, so
But if
I
we
have never seen like in.
no, we have seen, sir.
Okay.
Let us say in the Bailadila, where the high grade ores were mostly beneficiated. So the tailings itself were very rich in iron ore quantity. Yes, and they did recover from some tailings. And in fact, if I remember, even in Bolani iron ore mine, they also extracted some tailings from the.
Exactly. Yeah, again. Okay, so
In Goa also, I've seen in Goa tailings recovery of iron ore tailings as techniques.
again, most of the things like why I am emphasizing it is the environmental consideration, because if we look into the environmental consideration, then doing all these processes are not that easy. But if you ignore the environmental processes, then things are very easy to do that. Because I remember one of the leader, he was then the opposition leader in our Odisha assembly. He asked me a question, like it was 15 years back. He asked me a question that these coal ash, can this coal ash be dumped into a river? He asked me that question. I said, oh, forget about river. I cannot even dump into a creek like Nala, that small was. I cannot dump into the small was also. So how can you dump into the river? But there are some example, people think that river is so vast, it's flowing. If you dump it, environmentally good. So that's why I'm emphasizing more to environment. If we look into the environment, then all these processes, what we are doing, we'll have to be very careful, very cautious, and it's not that easy. That's why in US, Canada, where there are very, very important laws, whatever process we do has to be cleared by the environmental agency. So they don't allow to do anything like your fly ash. Fly ash you can use also in so many activities. Even underground mines, they are also using fly ash for backfill. Yeah, but in US and Canada, they are not allowed. Fly ash cannot be used in any. Only we use in some of the transportation or road projects I have used. That's only when we do the mixing. Like it cannot be used as a separate layer. We mix it with the sand and other things and to come up with some of the material properties we need, so that fly ash we can use there. Otherwise,
In India, for fly ash, a circular had been issued by MOEF to use about 25% of the fly ash in the waste dumps. But later on, it was found that it may not be practicable, so a study has been advised whether it is going to be beneficial or there will be further environmental
exactly.
concern.
Yeah. So if we consider the environment, then there are a lot of processes. We have to be very cautious on that. And why we consider environment? Because right now it is good, but 20 years from now, we will be forced to do that if we do not do now.
One question from Mr. Lingaraj Otta in YouTube. What is the substitute of tailing dam?
That's a very good question. I think the substitute is the recycle. People are working on it. Right now, a lot of research is going on. Few people, even in the private sectors also has approached me. And in US and other Europe, this research is going on. If we can recycle it, then that is the substitute. For example, the sand, the coarse sand coming from the tailings. I briefly worked on a project. The coarse sand coming from the tailings can directly be used in the construction. So then you don't need that. So If you can recycle it, then we do not need a tailings. Yeah.
Second question is asked.
Mm-hmm.
Ah. The second question is asked, which are the countries leading in creation of tailings dam?
Like again, right now, most of the countries are accepting GISTM, and the countries in Europe, even in the South American countries, and definitely US and Canada, they are leading in also all these tailings dams. Yeah.
Another question by Dr. B. Das. Green mining adoption can minimize the waste and tailings and thereby less load to the tailings dam. Please suggest your opinion on this.
Again the green mining is again coming back to the environmental side, because we are saying it will be a sustainable. It is not creating any further pollution or contaminations or things like that. And if we are looking into the environmental aspects, then we have to be careful on all these things, and we have to follow the design procedure correctly. So that will be the solution for the green mining.
One question by Mr. D.K. Mahanti, our senior executive council member. What is the concept of 40 years of life of?
No. The 40 years life means this is in the operation stage. Like I mentioned, the tailings dam is not over in 1 year or 5 years. It is continuous. Again, I worked on a tailings dam which they stopped in 2010. Then in 2010 it was only 500 feet height. Then again the mines come back. The mining production started. So after 10 years in 2020, they started expansion of the tailings dam. I was involved in that, and which was it will continue up to 2040, and it will go to a height of 1200 feet. So normally the operation of tailings dam is till the end of the lifetime, like end of the production, end of that mines, then we stop the tailings dam, and then it will be closed. It is no longer the tailings dam. It will be capped and closed and environmentally safe. We have to declare it.
Okay. One question by Mr. Jitendra Kumar Sadangi online. At what point of the tailing pond we should discharge our process tailings?
Means
where in the tailing pond, at which point we should discharge?
No, like if you see this upstream, downstream, and central line, we have the pond, like we have the dam, and then we have the pond. So in the pond, most of the tailings, the fines should go to the pond. That is where we store it.
Okay. One question another by Mr. D.K. Mahanti. If groundwater contamination takes place, what action need to be taken to keep the tailings dam alive?
Now again, the groundwater contamination, we do like in some of the mines, because I am working in the Arizona. In Arizona, our groundwater is, average groundwater depth is 800 feet. It is 800 feet deep. And we will have only shallow, like porched water, we say. And it's a completely dry climate. There is no water. But still there, we design cut-off walls. Like from the tailings, we design cut-off walls going up to some cases maybe 150 feet deep to protect the any flow of water into the groundwater. And also the liners. Right now, most of the agency, they want any new facility, should be lined. That's becoming the norm of the next generation tailings dam. Any facility should be lined.
There is a question from Mr. Shailendra Sinha. What are the unexpected reasons which can attribute to failure even after the best test done?
No, again, that's why, no, that's why the monitoring.
Yes.
The monitoring is the most important, and we will cover that in this course. And how we monitor and how we also, like I said, we should have the piezometer, because piezometer is the important data they will give me is the what is the pore pressure, because when we model it, we saw the most of the failure will occur because of the rising of the pore pressure. So what we develop in the model, then we put some numbers with the threshold value. For each piezometer, we'll put a threshold number based on our modeling. And then we will say that if the threshold goes beyond that, you stop it and do some remediations. So the monitoring is the most important thing, and again the proper monitoring.
Right.
That's the important. Yeah.
One question by Mr. Srinivas Suraj Prasad.
Mm-hmm.
Why used exhausted open pits are not used to backfill with the tailings? This will resolve the eco-balancing issue.
No.
Mr.
Okay.
Suraj Prasad, I think
Yeah.
many of the tailings dam now, I have seen one in
Open
Khandwan,
pit.
I have
Yeah.
seen in Nuamundi, they are in
Yeah. Open putting
exhausted pits.
putting on the exhausted pit. That's the one of the concept. Like I was working on a project where that was one of the alternative. Put everything, dump everything into the pit. But the problem with the pit is currently, like the pit is currently a hydrologic sink. But when you stop mining, what will happen? The groundwater will rise. Groundwater will rise when you stop mining. So when groundwater will rise, then definitely it will come up in contact with those tailings. That's why most of the in US and even in Canada, they don't allow tailings into the pit. But again, people think that they can line it, but lining a pit is not easy. It's very difficult because it's a rock. If we install the liner in a rock, will be very difficult. You can do that, but it will be very highly expensive to do that. And without lining, if you just dump it, definitely it goes into the groundwater.
One question by Sipali Das. What quality control measures are typically implemented for tailings dam, considering the potential environmental and safety risks associated with these structures, despite being composed of waste material?
Yeah. So that's what all we do. Mainly monitor it, and then during the operation time also we do lot of QA QC. Again, we use filter materials, and it's a lot of goes into that. Yeah, it's very expensive things. I can give you a like estimate of consultants value, like for Tailings Dam annually like $10 million million annually for a Tailings Dam annually. Recurring. I like when I started doing the tailings, we were doing like a simple stability analysis, limit equilibrium stability analysis we are doing. Right now, the client is telling us to do 3D model of the tailings dam. That is coming from the client side. Client is requesting us, I want a 3D model, because he has to show his investor that this is a good model and my tailings dam is safe. All these things is being governed by the investor. That's why this GISTM, whether country or agency accept it or not, but this investor will force all the owners to accept it. Because after October, like that deadline, August 2025, the investor will come up with a criteria. It is like a credit rating kind of criteria for each tailing sites. And if it is not compatible, then it might, they may have trouble to get any funding or any contribution from the investors. So then they will automatically go for that. Yeah.
With this, I think I must profusely thank Dr.
Okay. No, thank you. Thank you for arranging.
presentation as well as for the questions answers which he has given very
Okay. Okay.
Thank you very much.
Okay. No. Yeah. Finally, I thank Sujit Mahanti for arranging it so fast and within few days, and you all people came here to attend that. Thank you very much. And definitely we will. My main aim is to create awareness on these things, and I hope it will go with time.
Thank you. There is something left to be done. Just as a mark of love and respect on behalf of the society, I request our president to please do the honor of giving this small memento to the distinguished speaker, Dr. Panda. ना अपन बाहर पड़े इसमें बाहर पड़े बेटर हो फोटो Thank you. You can come, or you can sit at the front. You can sit. आपका सही लगा आपका लग गया अच्छा
I'll just give a sort of a concluding speech. This is an excellent presentation by Dr. Panda. I must congratulate him on my behalf as well as on behalf of the entire audience, even those who are online also. And since the metal industry is coming up, in a very astronomical scale, so more and more low-grade mineral is bound to be extracted and has to be beneficiated. Even in case of iron ore, we are thinking of BHQ, BHJ, banded hematite, jasper and quartzite, etc. So probably 60 to 70% will be tailings in future. Now the SR steel has gone also. So what they are doing almost with that zero concept. Actually, it's not zero. Their ROM is run-up mine is 50, 51 or 52%. First stage, their process is they put for upgrading, their recovery is 70% and 30% is slime. That 30% slime, what they do rougher cyclones and cleaner cyclones. Then they put it to HGMS, high gradient magnetic separation. So by that another 15% by recirculation. But when we go for this low grade this mineral etc., so naturally the tailing dam is of very paramount importance, and Pollution Control Board or the regulatory authority has to be very, very strict. I'll give you example. I was mines manager in Kiruburu iron mines. So when there is a jamming, so they cut this pipeline and they adopt the and entire this slime etc. discharged to the forest area. So the entire villages, I mean, their groundwater becomes red. And there was a question of prosecution on me. And we went for 60 wells drilling, and we ensured that not a chatank of slime should be discharged. So regulatory body has to be very, very strict. So with all this, I thank Dr. Panda as well as all our members like Sujit and Tirlochan Babu and others who have worked hard. This is a really a wonderful state-of-art discussion, and more and more future we will do. My friend Dr. Raja Ramani, who is quite famous in the world, he knows him very well. I'll try to plant him also sometime. He has obtained a Hall of Fame. A very large number of scholarships are, awarded also in his. With all this, I thank you all.
At the end, actually, I have the small duty of conveying our deep gratitude to our distinguished speaker, Dr. Bibhuti Panda, for his exciting presentation, and followed by the very lively question answer session. So that's why I also thank profusely to Mr. A.B. Panigrahi, who has been doing his job very genuinely and very perfectly. And I think we have come to an end. And at the end, I think I thank all the distinguished participants who have really gathered here physically and also online mode. There are so many participants there in the Zoom link and as well as the YouTube. So they have not only participated, they have also participated in putting a lot of questions. And these questions are extremely relevant looking at the topic that we have been discussing this evening. So that is the reason why it's a very satisfying end. So at the end, I thank and I convey our deep gratitude to all of you for making this event a grand success. Thank you all.